contract is suitable for creating the NFTs, but what we want to do is just gamify it a little bit. And that means by creating some kind of randomness where a user can create a random rarity, for instance, maybe add some kind of feeding feature, we'll see. But we're going to do this in this episode just to gamify it a bit. What we'll also add is a way for people to generate these lips, but for a fee. Because what you want to do is you actually want to use this contract to ask people to pay a little bit of a fee to create a lip, therefore they can use it in the game. Now let's get started. So the first thing that we're going to do is we have this get generate random DNA function, which we can actually rework and repurpose into something that we can reuse for creating randomness. So what we can do is let's maybe rename this function to create random num, like that, right? So once we have that, and we're not going to make it so that it takes in a string anymore. I think the reason for that is so that we can reuse it and we can actually determine the modulus amount in here. So what I want to do is let's just make this a uint 256, and we'll say, well, this is the modulus. Then the next thing that we want to do is, instead of hard coding this, we're going to say that it has to be the modulus of that, the modulus that we input. And then we can't use this string anymore, but we need some kind of randomness to generate actually the hash, which will give us the big number. So what we can do there is we can actually use the block.timestamp. Can't remember how it's spelled, maybe like that. Yeah, block.timestamp. And then also we can maybe concatenate that with the message.sender. So this will give us enough kind of uniqueness. The timestamp plus the user's address will create this hash, and then we're going to get the modulus of that. Now we need to update this because we've used it to create the random number over there. And instead of passing in the string name, this time we're going to pass in this number, right? So that we actually get this integer to create us this randomness. All right, so I see that it is complaining here on this line, and let's just see. So this is block.timestamp. Why? It says that the status can be required as a view. All right, so it means that we can't call this function pure anymore because it is requiring data from the sender and the timestamp. So all we have to do is change the pure function to view, and we should be good to go. Now this should all work again, and the reason why we did this so that we can reuse this create random number, and maybe we can reuse this to create the rarity before we save it in our lip. So as you remember, here at the top where we look at the struct where we constructed this object, we have a rarity field, which is a uint8, meaning that it can take any value from 0 to 255. So what we want to do is we actually want to create a number value between 0 and 100, or 1 and 100, and use that to determine the rarity of the object. So where do we do that? We can do this here on the create lip function just before it's created. So we can maybe say that, well, we're going to need a uint 256, or maybe actually a uint 8, because we're not going to use that much. Okay, and then let's just call this rand for the random number, but maybe we can say rand rarity is equal to, and now we're going to reuse the function that we altered, and we're going to pass in 100. The reason why we pass in 100 here is because we want this to be the modulus of 100, meaning that we will get a random number from 0 to 100, or 1 to 100. Not sure, we'll have a look at it now when we output it. But let's go ahead and we can see that it's red. The reason why is because it can't convert the uint 256 to the uint 8. So the easy change is to change this to uint 256 and it will all be fine, but I really want to use uint 8. I want to see if I can actually cast this, and how you can cast it is by wrapping the function in a uint 8. So we're going to convert it backwards. So it will give us a warning because we are not using the variable yet, but we are going to use it just in a second. As you remember, when we create a new lip, we have to specify the name and its ID, the DNA, and then the rarity. Well, sorry, the level and then the rarity. So currently 50 is hard-coded, but now we can actually put it in there for the random rarity. What does this mean for us? So currently we can actually now use this function, create random lip, which is public, and the public can actually create a random lip, and that is pretty cool. Now we don't even technically need this function to be in here to be passed through. We can actually cut that out too and put this in here as well, seeing that we are working with random numbers. So let's just pull this back. This will not take a DNA field anymore. It will just take a name. So we can take that name out. So everything will happen there. And then we will use the rand DNA where we had the DNA over there as well as there. Okay, and that would be perfect for us to now use and actually execute and create lips. The next thing that we want to do is actually ask the user to pay a certain fee for using our service, right? For minting an NFT that they can actually play with in the game. Now, where can we do this? So the only function that we really have is this public function that creates a hash lip or a lip, and it's public and it doesn't require any authorization. So the users can call this over and over and over again. You generally don't want functions in a smart contract that people can call over and over again. That's an exploit because people can just write a script that calls it and they will just pay the, what's it called, the transaction fees. And we don't want that. So what we rather want to do is we want to actually create some kind of fee for minting a NFT. Okay, now this touches kind of to the next tutorial that I'll be making, where we can actually create a website purely for minting NFTs to have on the blockchain. So it touches there a little bit, but it's not exactly that, because I'll show you in that next tutorial how to do this properly. For now, we just want to describe that we need a uint, and we're going to call this the fee. Okay, and the fee we're actually going to initialize off the bat. So we're going to say, let's make it 0.001, okay, ether. So just to stop here for a second, ether is a recognized global variable here in Solidity. It's there to help us, and so that we don't have to type out everything. Because if every smart contract works with way instead of ETH, so what I mean by that is technically, to specify this, you'll have to add a bunch of zeros, and then maybe at the end add this, you know, or 1, which is inconvenient because of the decimal points. So it's better for us to specify it like that, and then we can append ether at the end. You can also do cool things like say 1 days, you know, or you can say minutes, hours, and so on. It's just the global variables. Okay, so let's take this back. So we actually have 1 ethers. Now, I know it says ethers there, and we are going to be using the Polygon blockchain. So don't worry about that. This just simply says to us that it's going to be the fee of the main currency of the blockchain. And that's what I take it as, because that's basically what it, you know, what it states. But if you launch this on the Ethereum, it is Ethereum. If it's Polygon, you're going to be using Matic. All right. Cool. So the next thing that we want to do is actually find a way for us to change this fee for in case this fee was too high, or whatever the case might be. All right. So what we can do is we can actually create a function, and let's maybe create a function here in our helper section. So we can say function, and we can call this maybe update fee, and then let's open the brackets. Let's do it like that. We can make this an external function, visibility. So external basically says that this function can only be called from the outside world. It cannot be called inside the contract. It has to be called outside. So you can technically make this public as well, but there's no need because the contract won't need to call this. The next thing that we can do is add the only owner clause. And this is the modifier that exists and derives from the ownable import that we have. This means that only the owner will be able to update the fee, which kind of makes sense. The next thing that we want to add down here is say fee is equal to what exactly? We need a new fee. So in the parameters, we need a new uint 256 because that's the data type we want to use. And we're just going to call it the fee. So we can do that. All right, and that is it. Now we have a way to update the fee from the back, because once the smart contract is released on the blockchain, you cannot change stuff inside it, basically. Okay, so cool, that is fine. Remember, people are going to be paying for this creation of the lip. So let's go and see how we can do that. So what we can do is right before here, you've seen the require statement quite a few times now as I've been navigating through the other smart contract. The require statement actually is just there to say we require you to do this before you can continue. If the require statement that we're going to place in here fails, the contract will stop, it will revert and not change anything, and the function will actually fail. So what we want to do for a require statement in here is to say we require that the person who's buying the NFT or who's actually creating the NFT also sends us the exact amount of fee that we require for this object. So what we can do here is we can say that the message dot value. Now you've seen message dot sender before, but now you haven't seen value before. Now value is quite simple. As sender gives us the user's address, value gives us how much did this address actually input and send to the contract in value in ethers or matic and so on. So it's a simple calculation of just saying, well, the value needs to be equal to the fee. Okay, and there we have it. So we can actually just leave this like that. I see that it is moaning, and it's because call value payable. Okay, so this means that the visibility is payable, is public, but it's not payable. So we need to add the keyword payable here to tell Solidity and the contract that this function is payable. Users will be able to send polygon, matic, ethers to this function as they call it, and that's perfect. That means that this will kick off once this is right. It will continue to the next line and create the user slip. If it fails at this point, it will revert. What we can also do is add a comment. So in here it's optional, but you can write something like user, and this will show to the developers if this function fails based on this require statement. So we can add something like user does not have enough money. I don't know. So we can maybe say something like that. But that doesn't make sense. So let's just say the fee is not correct. This is basically for us to actually debug. So the user doesn't necessarily see this on their side, but we can use it at a later stage to just verify what went wrong. Okay, cool. So next, we actually can deploy this contract now and it will work perfectly, apart from one caveat. The caveat is that we will not be able to retrieve the matic that users have paid into this contract. You need to think of contracts as being their own wallets and addresses. They also have an address which can hold a certain amount of Ethereums or matic and so on. So when we do send this to the contract, it saves the matic inside this contract balance. So we would need a method, a function, and we can maybe put this also underneath the helpers to withdraw our actual money that we've made from the contract, from people minting, and so on. So we can say we want a withdraw function. This can also be an external function, and we only want the owner to withdraw this. Okay, the owner meaning it's us, the people who created this smart contract, and that will be you if you launch the smart contract. So inside the ownable class that we have also inherited from, we can use that to retrieve our owner's address. So what we can say is address, the address owner is equal to the owner, like so. So owner is a function inside ownable, and it will just simply retrieve back the address. And now it's fairly simple. We need to do a transactions on this owner object over there, well, owner address. So we can say, well, this owner, okay, transfer, and what do we want to transfer? We actually want to transfer the balance, okay, of this contract to this owner, meaning we want to retrieve it, we want to withdraw the matic or the Ethereums to our wallet. So how you get this right, you can say this, meaning this actually refers to this smart contract instance dot balance. But you can't just say it like this, because you need to cast this into an address first before you can get the balance. So what you'll do is before this, you'll say address, which we're casting this, and then you can say balance. Okay. So let's just quickly see why is it giving us a red hint. And basically, when you develop smart contracts, always check these errors. They give you a good idea of what's what's wrong or what's happening. So here it says send transfer can only available for objects of type payable, address payable, not address. Okay, so maybe we can then change this into a payable, because payable might do this. Let's actually take this out and let's try payable there. Perfect. Okay, because obviously this is payable, so we're gonna be calling it, and then the smart contract's gonna have to pay us, the owner, the matic or the Ethereum. So there we go. And actually now we have a very simple smart contract where we can mint NFTs. We can ask the users to pay for the lips or the NFTs that they create with this line. We can update the fee if we want to, and we can withdraw the fee. Now I'm going to test this out, and to make it a bit more simple, I'm going to make the fee 1 Ether. I think it's just better for us to observe and see what's happening then. So the next step is to actually deploy this. So let's clear out our previous deploys down there, and let's go and select our smart contract. Let's call this lips token, and we're just going to call this lips for the symbol. We're going to hit deploy. As soon as we deploy it, we can see that it was successful down here, and we have our contract instance. Now off the bat, you can see that there's this red button now, and previously it was orange, but now it's red, and the reason for that is because it's payable. This is actually a function that we need to pay for to use. And that's great, because that's our only entry point into the contract where people can manipulate and create NFTs. And we want them to pay a fee for that. So the next thing that we want to do is actually try and mint something. So let's mint an NFT, but let's kind of break it. Let's not pay for the NFT that we are going to mint, and let's just try it off the bat. By the way, if you want to send values and Ethereum with your call, you add it in here, and you can select your type over there of what you're going to be entering. We can change this to Ether so long, but we're not going to add values. We're going to leave it as 0 and see what happens. So let's mint the NFT. I'm going to mint Daniel again. Let's see if this will work. And boom, it doesn't. It fails. And you can see here's the error message. And interesting enough, if we scroll down, there we can see the fee is not correct. And that is because, remember, we added that line down here. This actually gives us a nice output. So if you didn't have this here, you won't see it down here, but it will still fail. That's why this is optional. It also adds to, I think, contract size, so use this sparingly. Usually you can just omit this and leave this out if you don't care about messages like these. Okay, but let's check if the smart contract will actually work, because we can do this a bunch of times and it will fail every time. But let's see what happens if we indeed send 1 Ether to the contract with this call. I'm going to click it, and it still failed. And why is that? Let's have a look. So we're going to say there's 1 Ether. Make sure the fee is 1 Ether. We're going to go down and say create. And it still fails. Why is this? So let's actually relook at our smart contract quickly, where we actually accept the fee. So here we are saying, well, we require the fee to be equal to the fee. Now, I don't know if this value is going to be exactly equal to the value. So I'm just going to say, well, we want the fee to be greater or equal to the fee, the message value, because maybe there's some way that's added in some case. I don't know. We just have to test this out. Okay, but the value seems to be correct. So I'm just going to do this. I'm going to close everything out. I'm going to redeploy the contract. We have a new instance. I'm going to try it again and mint a Daniel NFT. We're going to have a look at adding the value over there, and we're going to say create, and it still fails. So now we actually have to dig a bit deeper and see why does it fail. So the public over here is payable. The require statement states that the fee needs to be greater or equal to the fee that we have up here, and that is equal to 1 Ether. What I actually want to just try for a second is maybe send 2 Ether with this function and see it still breaks. And there we can see that we did send 2 Ethers with it. This might not be something to do with that functionality, so I'm just quickly going to have a look through this and then come back to you. Welcome back. Sorry for that. I usually don't debug code like this live on a video. The reason for me showing you this is because you will encounter these errors yourself. Now, we've missed a crucial part here in the compilation error, which was there all the time. And we can see that here on line 42, that was why our function wasn't working. It's because there was an error in our code and we weren't deploying the latest smart contract. And that makes sense, and you'll find this in your own code as well. So if we want to fix this, we can go there to line 41 and actually add the ending statement. Then we can see that there's still an error, and it says that this is not explicitly convertible to a payable address. So what we can do is we can say that, well, this will be address and it's payable, and then we also have to cast this into payable. Now, by doing this, the error should go away, And we should also see that we are ready to compile our contract. So this should work, and I think we're going to try this again, and this time it will be successful. So let's actually do that. Let's clear the terminal down here. Well, let's select our smart contract. Let's call it lips token, and we'll just call it lips for the symbol. Then the next thing we want to do is just deploy this, open the contract, and try this again. So here we go, and we have create random. So now if we just try create a random Daniel here, NFT, it should still break because we haven't sent any value through. But when we send 1 Ether with the transaction, it goes through successfully. And we've actually paid to create this NFT. I want us to do this maybe 2-3 times. So I'm going to say another one. Well, every time we need to add the value, right? So at 1, and then let's do it again. There we go. So now there's 3 NFTs that's been created, and we can verify this maybe by copying the address and saying balance of the owner. There's 3 NFTs, and because our cost was 1 Ether for 1 NFT, there should be 3 Ethers in this contract. Now, how do we see if there's 3 Ethers? Up here, you can see that our address currently has 96.9 Ethers in the account. And because we're the owner, I want to actually withdraw all the Ether that I have placed in the smart contract. Therefore, we can use the withdraw function. So when I click withdraw, hopefully we should get that back into our balance over there. So let's check it out and see if it works. I'm going to click withdraw, and it says everything went fine. If we go back to our account, we can see we have 99.9 again, and that works beautifully. Okay, so we actually have a working smart contract where users can mint NFTs for a fee. We are able to withdraw that fee. We also can create NFTs with rarity, and we can maybe display that in the game so long. But I hope up until this point that you've grasped the fact that a smart contract sitting on the blockchain is purely just sitting there, living on its own, and you can interact with it immediately. It's not tightly coupled to the front. So what we're going to be doing next is actually take you through a step-by-step process of setting up a React.js project with Truffle and Ganache CLI to kind of bind these two things. But I just wanted to make that clear that these two pieces of code is separate. The front end's going to be separate and the back end's going to be separate. We are indeed going to move our smart contract and deployments and migrations to the local blockchain, because currently we've been using Remix with the JavaScript virtual machine. But now we're going to be spinning our own blockchain up with Ganache CLI. We're going to deploy it there, and we're going to do everything locally. But that doesn't mean that everything gets tightly coupled at all. You can still carry on doing everything in Remix, deploying it with a Web3 provider, connecting to it with MetaMask, and still just do it like that. The reason why I'm going to show you how to use Truffle, Ganache, and React is because that's a much more solid, development space. There's many ways to skin this cat. I'm going to show you one. I hope you guys enjoyed this video up until here. And for the next part, it's going to be a lot of UI, a lot of front-end stuff. So if you're very good in front-end, you don't want to see those things, you know already how to connect to the blockchain, you can skip it. But if you don't know, stick around. I'm going to show you everything step by step. It's going to be awesome. And I think what I'll do is maybe deploy, not deploy, but change the smart contract and add more functionality once we have it in our local development setup. The reason for that is it's then easier to change the contract and test it out in the front. But when we get to that point, you'll see how easy it is to do this on your own project in the future. So stick around, and we're going to do that in the next video.